Isotopes are all part of the same element. However, they may have a different mass. This is because in each isotope, they have the same number of protons, hence they are the same element. However, they have a different number of neutrons. It can be more than the number of protons, it can be less, or it can also be equal to. So this causes a change in the mass because the mass is affected mostly by the number of neutrons and protons in your element. This also causes the relative atomic mass of the elements to be affected. It depends on how often these can be found in nature. What do I mean by this? As we know, we can find a lot of elements in nature. We can find hydrogen gas in air, oxygen, nitrogen, so on. We can find some elements in minerals. The abundance or how often you meet these isotopes determines the relative atomic mass. So this means, for example here, chlorine. Chlorine 35 is more common than chlorine 37. As you can see here, chlorine 35 is 75, while chlorine 37 is only found 35% of the time. So the relative atomic mass, the overall relative atomic mass, is determined by multiplying their total abundance among all isotopes by its original relative atomic mass. So in this case, it's 75 times 35 because the RAM of 35 chlorine is 35 and the RAM of 37 chlorine is 37. So that's why some numbers, some relative atomic mass of each element, they can be a bit weird. Like it isn't a whole number as we thought it would be because, well, they cannot be half a proton or a neutron. So that explains why chlorine is 35.5.